Welcome to the 72nd lecture of Digital Electronics. In lecture number 71, we have dealt with 1-bit magnitude comparator and 2-bit magnitude comparator. In this lecture, we are going to deal with 4-bit magnitude comparator. So, what is basically a 4-bit magnitude comparator? 4-bit magnitude comparator. So here you have two numbers A and B with the 4 bits, that is A3, A2, A1, A0. So you have B3, B2, B1, B0. So you need to check the three conditions. A is greater than B, second condition is that is G, then A is less than B, that is L, and whether A is equal to B, that is equality. So first of all, I will write the equality expression. For equality, what should be the condition? A3 should be equal to B3, A2 should be equal to B2, A1 should be equal to B1, and A0 should be equal to B0. Therefore, we can write for equality. For equality, A3 should be equal to B3, A2 should be equal to B2, A1 should be equal to B1, and A0 should be equal to B0. So how do you write the expression for that? So you will get E is equal to A3 x naught of B3 and A2 x naught of B2 and A1 x naught of B1 and A0 x naught B2. Okay. So from there we can check the equality. Now second case, I am going for greater than. Okay. For greater than case, I have four conditions. Right. So for greater than case, that is right, A is greater than B. When you write the condition for A is greater than B. Okay. That is the case G. This case. Okay. So what is therefore G? For G, the condition what we can have is A3 should be 1 and B3 should be 0. In that case, obviously you will get it greater than. Second case, if A3 is equal to B3, then A2 should be equal to 1 and B2 is equal to 0. That is second case. Okay. First case is A3 should be equal to 1 and B3 is equal to 0. That is the first case. Second case, if A3 is equal to B3, then A2 is equal to 1 and B2 is equal to 0. That is the second case. That means or if A3 and B3 are same, that is A3 x naught B3, then you should get A2 is equal to 1 and B2 is equal to 0. So you get A2 B2 bar. That is the second case. Coming to the third case, or if A3 is equal to B3 and A2 is equal to B2, that means A3 x naught B3 and A2 x naught B2. Obviously, which should be 1? A1 should be 1 and B1 should be 0. So you should get A1 B1 bar. Now coming to the last case, or if A3 is equal to B3, A2 is equal to B2, A1 is equal to B1. Obviously, A0 should be equal to 1 and B0 should be equal to 0 to get the condition of A greater than B. So, if these three conditions are satisfied, A3 x naught B3, that is A3 is equal to B3 and A2 x naught B2 and A1 x naught B1, then only which condition needs to be satisfied? A0 is equal to 1, A0 is equal to 1 and B0 is equal to 0. That means you should get A0 bar B0. Okay. So if any one of these four conditions, that means A3 B3 bar, that means when A3 is equal to 1 and B3 is equal to 0, obviously you can say that A is greater than B. Second case, if A3 is equal to B3, obviously A2 should be equal to 1 and B2 should be equal to 0. Second case. Third case, A3 and B3 are same, A2 and B2 are same. Obviously you can go for checking A1 and B1. In that case, A1 should be equal to 1 and B1 should be equal to 0. Next case, you can consider A3 is equal to B3, A2 is equal to B2, A1 is equal to B1. Obviously, A0 should be equal to 1 and B0 should be equal to 0. Now coming to the last case, that is for less than. For less than, it is exactly the ulta. Coming to the third case, that is A is less than B. We should go for less than. So I will write the expression for L. Here L is equal to, what is the first condition? A3 is 0 and B3 is 1. Right? So you can write A3 bar B3. Or if A3 is equal to B3, that means A3 H nor B3, then A2 should be equal to 0 and B1 should be equal to 1. So you should get A2 bar B2. Third case, if A3 is equal to B3 and A2 is equal to B2, obviously A1 should be equal to 0 and B1 should be equal to 1. So here what you get? You will get A3 X nor B3 and A2 H nor B2, A2 H nor B2. Then what you have to say? You have to take A1 is equal to 0 and B1 is equal to 1. That means A1 bar B1. Now coming to the last case, if A3 is equal to B3, A2 is equal to B2, A1 and is equal to B1, obviously A0 should be equal to 0 and B0 should be equal to 1. Then only you will get A is less than B. So you can have or A3 X nor B3, then A2 X nor B2, then A1 X nor B1. Then for less than, what is the condition? A0 should be equal to 0 and B0 should be equal to 1. So you will get A0 bar B0. You will get A0 bar B0. Now you got the expressions for equality, greater than and less than. Okay. Hope you have understood how to get the expressions correctly. Okay. Now coming into formatting a logic circuit for this one. First I will format for this equality. That is easy. So we have A3 B3. So here what do you get? H now. This is A3 X now B3. Then A2 H now, right? A2 B2 H now. This is A2 X now B2. Then A1 X now B1. This is A1 X now B1. Then A0 X now B0. A0 X now B0. So you should AND these four. 1, 2, 3 and 4. So if you are ANDing these four conditions, you will get equality. Now coming into greater than condition, A3 B3 bar and A3 B3 bar. So you can write okay. So yeah, do it also. So A3 is there, so I can write A3 B3 bar. A3 B3 bar. Then sorry, not the A3 B3 bar. Then A3 H nor B3. Then A2 B2 bar. You can write A2 B2 bar. A2 B2 bar. Then what do you have? A1 B1 bar. A1 B1 bar. A2 B2 bar. A2 B2 bar. A1 B1 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 A1. Oh, there's no space, so let me erase it somehow. Okay, so I can draw like this: A3 B3 bar, right? So you and that too. A3 B3 bar. Next one is A3 B3 bar, then A2 B2 bar, A2 B2 bar, this is A3 B3 bar, A3 B3 bar, and this is what? This is A2 B2 bar, A2 B2 bar. Then what I need to do with some other technique. Okay, so I will do again. So because this is a long circuit, I'll just erase this part. Okay. First one is what? First one is A3 B3 bar. So A3 is here, A3 is here, and you will get a B3 bar. So A3 is here, A3 B3 bar, and you can get from here. Then A2 B2 bar you can get from here. Yeah, that is it. Then A1 B1 bar you can get from here. This is A1 B1 bar, right? So you can get A1 B1 bar. The last one is A0 B0 bar. Okay. Now you need to add what? A3 B3 bar is standing alone, and A3 B3 bar is coming out separately. So you can take out A3 B3 bar. A3 B3 bar is coming out separately. Then A2 B2 bar along with this one. A2 B2 bar along with A2 B2 bar. But that is along with what? That is along with A3 B3 the whole bar. Yeah, that is coming out. Then so here this should be along with which element? This should be along with, that should be along, A1 B1 bar should be along with A3 B3 bar and A2 B2 bar. So that should be along with three elements. So this one, then yeah, this command should be along with this A2 B2 bar. Yeah. So this is the second element. Now coming to the third one. Third one means you should have all this A0 B0 bar. That should be along with all these things. That is A3 B3 bar, A3 B3 bar, A2 B2 bar, then A1 B1 bar. Yeah, A1 B1 bar is not taken anywhere. And then A1 B1 bar, and you should AND it. You should AND it, and these four things should be ORed. These four things should be ORed. Okay. So this is therefore greater than. This is therefore greater than. Now coming into less than. Coming into less than case. So how it is coming to less than case? Less than case means obviously it is the ulta thing. And if you are taking okay, so I have drawn for greater than. Now you can go for less than. Less than means you can go like this. So it is a bit in the reverse order. You can go with A3 bar B3. Get so I will draw it here separately. A3 bar B3. A3 bar B3 is here. Now A3 XNOR B3. So since that terminal I am taking it here. A3 XNOR B3 and A2 XNOR B2. A2 XNOR B2. That terminal I am taking here. A2 XNOR B2. A3 XNOR B2. A3 XNOR B3. Okay, that along with the A2 B2 bar. Okay. So A2 B2 bar. So that along with the A2 B2 bar. Assume that some operations has been done before that. Now A2 B2 bar. Then A3 let me erase this. There is a space constraint over here. So here we will go with the other track to get the less than case. To get the less than case, so what we have is here you will get the greater than case. So to get the less than case, I will go with it. So you get this is A B bar. A B bar means if you need to get A bar B, it is the exact ulta. So we can get either we can take from this point or A3. I will take, if I am taking from this point, okay, go like this. This is A3 bar B3. This is A3 bar B3. A3 bar B3. Okay. Now coming into next term, that is A3 XNOR B3. A2 B2 bar. A2 is here. A2 is here. I will take it to the top. A2 bar B2, right? So B2 is coming here. I will take somehow. I will take that along with A3 this one, right? So here you will get an AND gate. Similarly, you will get 4 things and you should OR it. Similarly, you will get 4 elements and you should get OR. Okay. So that is a brief circuit because this is a very big circuit. So I am not going to draw the entire thing. I think you have got the concept. So I have drawn the greater than circuit and less than circuit you have to draw. Okay, and you have to draw for this one. Another technique is you can draw equal to separately, greater than separately, less than separately. Okay, but only thing is that you should have the same points here. Okay, you should have the same points which is taken in. Okay, so that is up to you. And anyway, okay, because this is bit tough to draw the less than. I will try to draw it in a different pattern in 3 pages. I will try to draw it in 3 pages, and you should just do it. Okay, it is also possible. First case is equality case. First case is equality case. That is for E. E, what I have is A3, B3. What is that? It is XOR. A3 XOR XNOR, right? Okay. So I am taking this as X1. Then A2, B2. I am taking this point as X2. Then A1, B1. A1, B1. I am taking that point as X0 and that take point as X3. Then A0, B0. I am taking that point as X4. Okay. So I am having X1, X2, X3 and X4. Now how will my expression be reduced? This is X1. This is X1, X2. This is X1, X2, X3. Okay, so this is X1, X1, X2. This is X1, X2, X3. Okay, so that is all. Now coming into this one. Now equality is not there, so I have drawn the four things: X1, X2, X3, X4. Now you can take the point. You can take X1, X2, X3, X4. If I am ANDing these four, I will get equality. Okay. Now coming into next one. Next one is what? Next one is greater than. So equality is over. Now coming into greater than, I have A3, B3 bar. Okay. I have A3, B3 bar. Okay. A3, B3 bar. That is there. Okay. Then A3, B3 bar. Then H1, A2, B2 bar. H1, A2, B2 bar. That is there. Then next one. H1, X2, A1, B1 bar. H1, X2 is there. Then A1 bar. Sorry, A1, B1 bar. This is A1. A1, B1 bar, right? If I am ANDing these four, you will get that. Now one more time is what is it? That is X1, X2, X3, A0 bar, A0, B0, right? It's not A0 bar, sorry, there is a mistake over here. So you should write it as A0, B0 bar. Right. There is this A0, B0 bar. Yeah. So you should get H1, X2, X3. H1, X2, X3. Then what? H1, X2, X3. Then what? Then is A0, B0 bar. A0, B0 bar. Okay. If I am taking these five elements, okay. Now if I am summing up these five elements, that means using an OR gate, I can do it, right? So I am summing up these elements. Using an OR gate, a 5-input OR gate, so we will get greater than. This is for greater than. Okay. So I have shown an easy way, because I have shown it in a symbol format or in a signal flow format. Here this H1 is taken here, this X2 is taken here. x3 is taken here. Okay, so I have not I am drawing the circuit part by part, because drawing that entire circuit is a bit tough task in this kind of platform. So I am drawing it part by part. So this is for greater than. Okay, now coming to less than. Anyway, x1, x2, x3 is x4 is there. So this is for greater than. Now coming for less than. That means less than, that is a less than b. Okay, so what is the first element? First element is a3 bar b3. a3 bar b3, that is the first element. What is the second element? Second element is h1 a2 bar b2. h1 a2 bar b2, that is the second element. Now coming into what is the third element? Third element is h1 x2 a1 bar b1. h1 x2 a1 bar b1, right? So that is the third element. So you have AND gate over there. Now coming to what is the last element? Last element is h1 x2 x3 a0 bar b0. Yeah, h1 x2 x3 x1 x2 x3 a0 bar b0. Okay, so that is the last element what we have with the 5 inputs. So I am drawing a 5 input gate, and now I am ORing these things. Okay, if I am ORing these things, what will I get is error. Okay, hope you have understood. Okay, so no need to stick on this figure, so you can go in this way also. Okay, so for equality, greater than and less than, you can draw 3 circuits, but only thing is that you should get the nomenclature as a signal flow graph. That means x1 goes to here, x2 goes to here, and x4 goes to that. Means x1, x2, x3, x4. If all 4 are there, you should get equality, and this is for greater than, and the next one is for less than. Okay, so you can draw the circuit likewise. You can draw the circuit part by part. That is also a correct form of representation. So I think you have got the concept of 4-bit magnitude comparator. Okay, so in this lecture, from where we have started with an introduction to lecture number 71, and written the expression of 4-bit magnitude comparator for which are things: equality, greater than, and less than. We have written the expressions, and we have realized the expressions using gates, basic gates. Basic gates means for equality checking it is XNOR, and apart from that we have used only AND and OR gates. So we have formed the circuit for equality, greater than, and less than. Okay, so that is regarding 4-bit magnitude comparator. And with this lecture, I am concluding the topic of comparators. Thank you.